Hello everyone, welcome to this course. We are going to discuss about the most fascinating application without which we cannot imagine our life nowadays. Yes, we are going to talk about the electromagnetic field. Hello everyone, I am Dr. Sohail Rana and we are going to explore electromagnetics in 3D. This subject is considered as one of the toughest subjects in physics and engineering. What I observed was that we need to adapt methods differently for understanding the problem. Actually, the main problem in understanding this subject is that the concepts explained in textbook are given in 2 dimensions. But we have to understand the concepts of this subject in 3 dimensions. So that is the place where most of the students get confused and feel that this subject is difficult. So here I am trying to focus on removing fear of this subject by explaining it in simple language with necessary examples given in 3 dimensions. The first objective of this course is to provide necessary background of electromagnetic fields to the learners, which will be useful for studying advanced subjects such as antennas, microwaves, and wireless communication. Second goal of this course is to expose learners to the laws of electrostatics and magnetostatics, which will lead to understand the Maxwell's equations for static and dynamic fields. This course will also familiarize the learners with the principles of uniform plane waves, antennas, transmission lines, and wireless communication. And the most important goal of this course is to enhance the imagination skills of learners for physical interpretation of mathematical formulations in 3 dimensions. Now let us discuss to whom this course belongs to. This course belongs to a wide range of learners from UG and PG courses related to electrical, electronics and physics. This course belongs to who want to prepare for GATE and IIT examinations. This course is also useful to the students who wants to understand basics of electromagnetics. What we are going to do to make this course students friendly? We want to increase the quality of education and implement the outcome-based education. Students have a lot of confusion about what is outcome-based education. For achieving outcome-based education, we are going to use 4 different methods. It involves in-class sessions, 2D presentations, software and hardware demos, and most importantly 3-dimensional animations, which will give more clear idea. In rest of the video, learners will get a clear idea about the methods I am going to use. It will be followed by a 3D animated video explaining Coulomb's law, which is very important in understanding the concept of electrostatics. Welcome students. Today we are going to discuss the first topic of electromagnetics. In this subject, it is very important to have a good amount of imagination. With imagination only, we can make this subject interesting and easy. You have to imagine yourself in space, like you can see in this image where a triangle is visible. This is the front view of this image, but if we want further details, we have to go into the Y and Z axis. Now you can see that it is in actual a prism. So the very important thing in this subject is imagination. Let us begin with our discussion. Our discussion starts with the very basic element of the universe. Everything which is present around us is made up of atoms. Atoms are very small particles. Yourself, myself, the trees, the rivers, the planets, everything is made up of atoms. And these atoms have charges inside them. We have two kind of charges. One is positive charge and other one is negative charge. All the atoms have electrons rotating inside themselves. Now if we imagine that there is no bonding, then everything will break down and it will be scattered. The bonding is very important. The space, we have the force, and these charges, which are very tiny particles, we have to imagine them in a broad way. Let us compare them with the sun and solar system, where we can see there is a sun and there is a point we are representing in a zoomed way, which is nothing but a sphere. But I think we should make this sun more proper and more emissive. So let us have this sun which is emitting light in the entire surrounding region, and the charge which is available around that particular sun is very tiny object compared to sun. But a person is a person no matter how small. These charges, they also emit the force lines around them. If it is a positive charge, the force lines goes outward as it is shown here. If it is a negative charge, the force lines will come inward. All the charges, either it is positive or negative, they exert some kind of force in the surrounding region. If there is no force, then what will happen? Everything will fall down. Like we can see in this particular image, there is a sun and there are the planets rotating around the sun. But if we remove the force and bonding, everything will fall down. But luckily, we have Newton's law. Sir Isaac Newton formulated gravitational theory around 1666 after watching an apple fall and asking why the apple fell straight down rather than sideways or even upward. He showed that the force that makes the apple fall and that holds us on the ground is the same as the force that keeps the moon and planets in their orbits. Let us now compare Coulomb's law with Newton's law. Newton's law gives relation between two masses. It states that force between two masses is proportional to the product of masses. On the similar lines, Coulomb's law gives relation between two charges. It states that the force between two charges is the product of charges. Let Q1 and Q2 be these two charges as shown in this animation. It is an experimental law of physics that quantifies the amount of force between two stationary electrically charged particles, as we know that similar charges repel each other. If the charges are opposite in nature, one is positive and another one is negative, they will attract each other. Coulomb's law states that the force between these objects is inversely proportional to the distance between them. Say R or D is the distance between them. It is a very common logic that if any object is going away from another object, the force between them reduces with the distance increased. If someone's proximity with another object increases, the force will also increase. The force may be attractive or repulsive. If we combine these relations, we find the Newton's force is proportional to the product of masses by R square, and the Coulomb's law is proportional to the product of charges by R square. The constant of proportionality used in Newton's law is G, which is gravitational force. The constant of proportionality used in Coulomb's law is K, which considers the permissions given by medium for the proximity of charges. Electron is an example of tiny negative charge, but this tiny element is root cause of all the currents and all the communications we have around us.